So today we'll be covering trigonometric graphing and how to plot and stuff like that. Before we get into that one, could you all open the red book, please? And this is something that's very important for me to know. Could you go through this red book? I think there are 4 tests in it. Check if there is any science test that has not been done. Somebody check test 1, somebody check test 2, 3, and 4. So I really need to have an idea if there's any science test in that book that's not been done.
I don't think we did test 1. Or, no, this is test, wait, which test is this? 4. No, it's test 4. Yeah, I don't think, well, hold on a sec. Well,
That's just the test. It's science, so it's always 4.
Which test?
oh,
It's
That's what I have in my notes. Test 4 is not there. So test 1 done, right?
oh,
Test 2. Look at the index sheet, look at the table of contents, and just look for it. So simple. The one I have is test number 4, science is not done, but I want to just double check that. Any luck? So test number 1, done? Wait, why are we not, yes or no? Test 1. How about test 2? Test 3?
Yeah.
Test 4? No. So the only so far, the only test that's not been done was test number 4, right? Science, okay. Good. Could you check test 4 science, sorry, test 4 math, if that's done or not? Test 4 math. If you're in test 4 science, a few pages before that. No. It's not done, right?
I did those. I don't know if you've done them here, but I did the science, or the math and the science for test 4.
Maybe at home as a practice.
Yeah.
Okay. All right. All right. So let's focus on this one now. What I would like you guys to do, keep the red book away for some time. We'll be working on that later. But I just want to finish off this one. Right now, the only thing I need from you guys is your calculator in degrees mode. All right. So, in the ACT, usually the last 5 to 10 questions, you expect a problem on trigonometric graphing. Sometimes there will be a question, sometimes there won't be any question. So, I've seen people make it sound really complicated, it's like it's difficult and stuff like that. It's not. And it really helps you guys to know this well, especially for physics. All right? Now, how many of you taken chemistry, high school chemistry? Okay, all of you. Okay, in chemistry, you should have studied behavior of light. Have you? How does light behave?
Like a wave.
Huh?
A wave.
Wave or a
Particle.
particle? Somebody say particle. What's a particle called? Photon. Called dual nature of light. See, that's what I teach. I teach undergraduate chemistry, so this is my cup of tea. What does it mean that light behave as a wave? Light actually moves like this. Okay? Light moves like this. Or light moves in a form of a particle. So, there are different models of atoms. There are three famous ones. The third one is called the Schrodinger's quantum mechanical model, where he treats an electron as a wave, because electron does not have a whole lot of mass. You guys with me? Called the Schrodinger's model. So what we're going to do today is to understand what wave is. First, what is this distance called?
Amplitude.
Amplitude. That's your A. Okay? In this case, the amplitude is 1. Okay? What is the top part of the wave called?
Oh god, it's like called a
Crest.
cross.
What's the bottom part called?
Trough.
Trough. Get your notes, go ahead and write on this. I'm just check it out. So I'll have to manage both. I don't know why Alina is not here, but I'll have to manage both, okay? But they're taking a test, so I'll calmly finish this one up, okay? Get your calculators, go to graph mode. First, in the windows, what I would like to do for x minimum, do negative 360, that's negative 360 degrees. X max, 360. Y minimum, that's your amplitude, it'll be, let's go with negative 4. Y max, make it as 4. And then plot y is equal to sin x, which is the parent function. And I want everybody to show me calculator.
No, mine's a 2.
Can't help it, guys, if you don't have your calculators.
But would you be able to do like on decimals? Or no? Oh, okay.
Try it.
Oh, yeah, we'll see.
So, I hope you guys get a graph. Should look something like this. Yes.
On what? I did it.
I don't know that calculator, but we'll see. Oh. Is it in radians? Yeah. I have a big belief that it's in radians. Change that. Yeah.
I think something like this, except like, but like with restrictions. Or
You guys got it, Ethan? Just, that- all right, so this is y1, you have sin x. In y2, do not erase y1. In y2, make it y is equal to sine 2 sin x. 2 sin x. Am I right?
Mhm.
So has these points changed?
no.
So these are called nodal points. Okay? And this is called a nodal plane. So when you change the amplitude, the points, the planes don't change. Guys, what? Good. This is called a complete wave. Crust, trough. This is called a complete wave. So actually, you'll be surprised. Many people do not know the definition of a wave. This is a wave. Sounds good? For a sine and a cosine, oh, I'm gonna draw two waves here. One, two. This is a direction of propagation of the wave. What's the difference between this wave and this wave?
The second one has a higher amplitude.
Let's assume that the frequency amplitudes are same.
Oh, okay. Well, then the wave lengths are shorter.
Yeah.
The right wave is moving at a different angle.
Let's say the angle is same. Yeah.
Is it frequency?
So the right one has more waves per second. You with me on this? More waves we have, more cycles we have, more in a fixed amount of time. So this is called higher frequency wave. So what makes a higher frequency wave? If the distance between these 2 points called lambda, the wavelength. Lambda reduces, frequency increases. You with me on this? So this has a higher frequency and a lower, shorter period. And this has a higher period, smaller frequency. Because period and frequency are inversely related. So, frequency is inversely proportional to period. Sounds good? And for sine and cosine, period can be calculated as 2 pi or B, and this is your B right here. You got this? So you are plotted in your graph y is equal to sin x, y is equal to 2 sin x. Am I right? Yes? Now y3 plot y is equal to what? Sin 2x, please. So don't delete the y1 and y2. Include y3 sin 2x.
So. Oh. Okay, so you just. Oh, that should be right. Okay, well, then I did it. I think graph it.
You guys got it?
That's weird. Well, I don't know, well,
It says error, my right, traffic graph.
try deleting the other graphs.
Okay, see.
That's weird. I've never seen that.
Invalid dimension, so the dimension is not right. Was it working for first two? That's really weird. Okay. Look at sound. Okay, let me try something. Here you go. Yeah, don't worry about it. It's like that. Yeah, it's a pretty. It's something called stats off. You have to go back and do the stats off data points. Yeah, don't worry about it. Learn the hard way that one. Okay, so y is equal to sin 2x. So what happened here? So the amplitude is same as this one, am I right? But look at what happened to the period here. Period for this one is 2 pi over 2. This is the 2. So period is pi, which is nothing but 180 degrees. So between this and this, the period itself changed. You with me on this? Now do one thing. Go ahead and remove y2. Keep y1 and y3 and plot it, please. You'll have a better picture because the y2 can be confusing. The first one is sin x. So which one is a higher frequency wave? Sin 2x, sin x. Because the period got reduced, frequency got increased. You guys with me on this? Good? Okay. Go ahead and run on this, please. Good. So let's good with this one now? Okay. Now go to y1 sin x. Okay. Now remove all other graphs and include y is equal to sine x minus 45, please. X minus 45. The reason you're using 45 degrees because your mode is in degrees. You got to be very clear about that. Okay? Alright, so this is y is equal to sine x, right? So what happens? X minus 45. So you literally took the wave and moved 45 degrees to the right. You guys with me? Yes or no?
Yeah, yeah.
So, when you have negative 45, why does it move to the right? Here's a simple reason. You have to take 45 off minus 45 to go back to the origin where it started from. You work on this. People always ask me, when it's minus 45, why does it move to the right? Here's a simple reason. Because you have to do minus 45 to go back to the parent function. You work on this. That's why it's a shift to the right. Making sense? Sure about it? Okay. This is called horizontal shift. This is called horizontal shift. Question?
What? Oh. Well, I guess like why does it only move like 1 unit?
1 unit? What do you mean?
Yeah, like when I pull this up, it said like why does it move like 45 like 45 units that way?
Oh, because your scale is not there. Your x-axis is in number 1, 2, 3. It should be 45 degrees. Each unit is 45 degrees for you.
Oh,
Yeah.
I see.
Mhm,
Okay,
mhm,
okay.
mhm.
That makes sense.
Yep. Now, so you have y is equal to sin x, y2 is sin x minus 45. Do this for me, please. y3. Please. Y is equal to sin 2x minus 45. Okay. So remember, what does this affect? This number. This affects the period. What does this affect? The horizontal shift. So you're affecting both the horizontal shift and it's affecting the period, called phase shift. And phase shift is calculated as 45 degrees, that's C, divided by B. Which is 22.5 degrees. To the right, because it's the minus. So if they ask you to do the phase shift includes two things. There is a period change, then there's a horizontal shift change. Making sense? I expect these two questions to be very likely questions. Cool? Are you guys making sense? Okay. Of course, the D one is the easy one. This is the horizontal, this is the vertical shift here, D. Whether you take the graph, the wave, move it up or down. You guys looking at this? Okay, I'm gonna repeat this because this is something I've seen is a frustration for me. When it is in degrees, your calculator, everything has to be done in degrees. You with me on this? Okay. So go ahead and clear the whole calculator, just clear off everything. This was an exam question, okay? first write this in your notes. And I'm gonna tell you, I'm gonna do one question that includes everything here. Half sine x over half x plus 90 minus 2. All right, tell me what is this stands for? Down 2 or vertical shift, which is down 2. You guys know that. What is this called? Amplitude. Is amplitude, what does amplitude measure? General term? Distance, right? So it can amplitude be negative? No, amplitude measures distance, distance always is positive. Good. Now find period, please. I want you to find period of this, phase shift of this, period and phase shift of this. Good. Make sense? The only thing I included was a frequency. Frequency is inverse of period. If period is 4 pi, frequency is 1 over 4 pi. What's the unit of frequency? Unit, the label. You guys told me that you took chemistry, high school chemistry. You should answer this.
Lambda.
What's that?
Lambda.
Lambda is for wavelength. That's a Greek alphabet representing wavelength. The unit is not lambda. Yes? Hertz. Hertz are, in simple language, cycles per second. Hertz is cycles per second. Hertz was a scientist. Sounds good? So here it is 1 over Hertz. You guys got this one? Come on, let's go and plot this in the calculator. Let's see how you're gonna change the window. Make it look nice to me, okay? Your calculator, the graph should look nice. Make it look nice. see? Okay. If I have somebody else, I wanna see if it's good enough. It's okay. You could make it look better, that's okay. Yeah, that should be okay. See, the point here is the amplitude is half, right? So you do not wanna maintain these units here for Y, right, if it's half. Right, that's what I'm saying, you gotta adjust it, make it look nice. Of course, there's a negative half here, negative 2 here, so right? So you can start with a, maybe 0 or 1 as a Y max, right? And so that the graph should always be in the middle, so it looks nice. You with me on this? It's not just plotting, it's about skill. All right, so I feel you guys are getting comfortable with this, right? Okay. Yes or no? Okay. Now this is important. Page 4, please. Page 4 of the math packet. Because if you know sine, cosine is exactly the same. There's nothing. The period is same, the frequency is same, all the stuff is same. So I'm not going to spend time on that one. But there is something I want to spend time. Is the odd and even functions. Do you see that? Odd and even identities at the bottom. Okay. Good. This is important. Get a calculator, please. Do sine 35 degrees. What do you got? No, not in the graph mode, guys. Not in the graph mode. Normal mode. What do you got, sine 35?
0.57.
Okay, 0.57, right? Do sine minus 35. What do you got? Negative 0.5. So can I make this statement? Sine of negative x is equal to minus sine x. Yes or no? Yes or no? Am I right? Sine, okay. This is called an odd function. It's called an odd function. Go to graph mode. Make sure you have these standards. I usually start with this. This is always my routine. When I do any plots, I always have this as my routine. Kind of gives you a pretty good idea. In y1 plot y is equal to sine x. In y2 plot sine negative x, please. What does it look like? Looks like a DNA, right? Because you have a negative function. So when I ask people, when I always tell people, if you cannot visualize the DNA, do this, and just flip it 90 degrees. You get a pretty good idea how the DNA looks like. You with me on this? It's not exact like that, but pretty good idea. Double helix structure. You guys with me? All right. Now go back to normal mode. Do cos 35, please. Cos 35. Then do cos minus 35. What's that? So cos minus x is equal to cos x. Am I right? So it's an even function. It's an even function. So go to graphing mode, please. Okay. Go to graphing mode, please. Plot cos x and cos negative x. Keep it moving.
With the sign guys?
No, no sign. We don't need sign is done. Keep an eye on the graph, how it plots. Keep an eye on the graph. How many curves you get? Just one, right? Because cos x is equal to cos negative x. But sin x sine negative x is minus sine x, you get a kind of double headed structure. You guys remember this? Everything with cosine is exactly the same. This is same, everything is same, it's just the starting point changes. Because sine 0 is 0, but cos 0 is 1. You with me on this? Sine 90 is 1, cosine 90 is 0, so they have the extremities right there. Okay? But everything else remains same. Which leads to the last topic, y is equal to tan x. So here's what I would like you guys to do. Go to window, make this negative 180 and positive 180. And plot y is equal to tan x. You guys got the graph? Can you visualize it? Okay, now we're gonna get into a little bit detail on this. It looks weird, right? It's kind of cuts between cuts, basically. Here's why. Go back to normal mode, please. Do tan 0. Tan 0 is 0. So it's right here. You with me? Do tan 45, quick. Tan negative 45. What's that? Negative 1, right? So it's an odd function basically. You with me? Okay. Do tan 90. Error. Tan negative 90. Error, okay? So what does the error mean basically? So to make a life a little easier, let's get a perspective on this one. Do tan 89.9 degrees, please. Do that. 572.95. It's a big number, am I right? Yeah. So what happens at tan 90? It becomes infinity. So this is at 90 degrees. Okay? This is a tan negative 90 degrees. So what happens is we have what's called, you guys should know this, it's called a vertical asymptote. That means it's getting higher and higher or lower and lower, but it's not gonna reach that line. So at tan 90, does the function exist or not existing? Not existing. That's the definition of asymptote. You with me this? Okay. So sine and cosine, the period was 2 pi over b. Do you see that one? This is the for sine and cosine period, 2 pi over b. For tan, the period is pi over b. Pi over b. Of course, in this case, b was 1. So this is pi right here. You with me this? 180 degrees. 90, 90, 180. This is your wave. Are you with me this? As you play around with b, the period starts to change. Now do tan 2 pi, please. Do tan 2 pi. Keep the tan pi, tan x, sorry, not tan 2 pi, Jesus, tan 2x. You guys, no, go to graph mode, I mean, sorry. Go to the graph, first one is tan x, y2 is tan 2x, please. Sorry. Keep an eye on how the graph gets plotted. That'll give you a pretty good perspective. So you have more waves, right? Am I right? Fundamentals don't change, period, and frequency relation doesn't change. Making sense? Yeah, this is usually I don't get time to teach this. Probably after a long time I've got a chance to teach this. here's what I would like you guys to think about. When you get a problem on this one, the first thing is, can I answer this using a calculator? First thing. Second, is it in degrees and radians? Okay? Third, your calculator has so much ability that you can get this done in the calculator. You with me on this? Now, so let me tell you what's this question. I want to go back to this one. So they gave this one and they said, which of the following graphs matches this equation? How would I have done? I would not spend any time then to plot it and see which one matches. You with me on this? Anything else, you just are wasting your time. You with me on this? You just are wasting your time. All right, so here's the plan for the remaining part of the class. Elena will be here in another few minutes. She'll start with the science test. She'll do a full-blown science test. That's next Sunday is, of course, is the Thanksgiving holiday, so I hope you guys will have a good Thanksgiving. I really also hope that you're going to use this time to study and prep, because majority of you are taking the December test. Am I right? Raise your hands who are taking the December test. You're not taking the test?
In February, I'm taking that.
Okay. Well, so you have probably a lot of people taking, and I hopefully for a couple of them, or at least 3 or 4 of them, this is your last test. Ryan, William is not there. I hope this is your last test. I really do. If this cannot help you, I don't know what else, unless the test is off the charts weird. But I can tell you one thing. The difference between a 36, a 35, and a 34 is the amount of practice you've done. I cannot emphasize. What does a 34 say? That you know your shit well. You with me on this? That's all it is. They know it. But what's the magic of a 35 and 36 is the determination. You with me on this? How bad you want it. Like today, for example, it's been tough. There's a lot going on my professional stuff. But I don't miss class. You with me on this? I'm going to be here December 8th, the last day of the class. I already told the client. You don't want to miss the last day of the class, because I'll be covering ACT writing and a science test. You with me on this? You don't want to miss that class, I can tell you right now. And I won't be giving that science test outside of this classroom. I can't. So I'm making copies and stuff. How many are coming to the December 7th review or attending this review? 1, 2, 3, 4. Are you guys coming to Dunes, or are you going to be doing it online? Okay, I need to know that quick, okay? If you come there, it's great, because you'll have, but you don't have to. We'll be sending all the materials you need, all right? Fair enough? Okay. Do you think you guys have prepped enough for math now? We did probability stuff. I think the problem which William was asking last time, I think that would answer 3.5% or 3.6% seemed right to me. I really think. We had a pretty interesting discussion last time. Ryan, what did you get in math in October test?
35, I think.
Do you know which question you made?
You got a
No, I
three.
got 36 in that. Yeah.
You got a 36? You got a perfect score? Okay, good. So does it mean you got all right?
I don't know. We have we ordered the test things back, so. I
You
can
won't
see-
get this. This is the October test. You won't get that thing back.
Oh, you won't?
Only April, June, and December.
Oh. I don't know.
Yeah, your dad told me that you composite score. I didn't know your breakdown scores. So which one did you?
I got 30 on the science, which really surprised me.
What?
I didn't know, yeah. And then I got 34 English, 35 reading.
Well, I'm surprised. I was expecting a 36 in English. I knew you would be between 35 and 36 in math. Wow, that surprises me, man. Okay. Well, you have some work to do. So, okay. Again, I really believe you guys have a huge potential. People think I'm just telling this. You can come and sit in my other classes where it's if not there, I'm not going to tell you this. I strongly believe this is one of the, as a group, one of the best groups I've taught as a group. But I also feel that the amount of work you guys put in is also not that great. Smartness is one thing. You guys have that. You'll do well in your careers, I know that. Question is how well, right? That's what I think I can decide right now. How many practice tests did you take? Full practice tests.
3 probably.
Okay. Average is 8 in our company. 8. So I'm expecting you to take at least 2 more. And it's not about 34 is great. Tier 1 score is 34 plus. It's not that. I told you, it's not 34 or 35. The question is what you deserve. That's what you need to be focusing hard. Now I want you guys all to think about this, okay? So if you're a 32 student and you get a 32, I'd say, you know what, congratulations, you did your job. You're done. You with me on this? So I had a student who, well, I was coming to Sioux Falls today. She's my student. She took our summer class and she got a pretty good score. And they were like very happy. I said, you may be happy, but she doesn't deserve it. She deserves much more. You may be happy, you may be done. I wouldn't, because this student needs to get at least a 32. If she gets a 32, yeah, then you can close your, and stuff. You know what? That's because I know kids' potential. I know exactly one of you here and say, okay, how much each one of you should get, and when is your, and I say when, okay, now you're done. I've done this for 6,000 students. So I can tell you, just by sheer experience, in first 4 weeks, I usually have decided your scores. Ask Carter and Ryan. I actually contacted your dad when you guys were in fall class and said, you guys need to be taking the spring ACT class in advanced class. No, I told him because I see a potential. You with me on this? It's not what you get. Even if you had got a 33, it's a great score, but I would have said, no way you'll be done. If you get a 35, I said, yeah, now you should be good. The 36 thing is more of an ego thing than anything else. But, like, you know what, like Liz got a 35 and she took it again, got a 36. That's more of her thing. But I don't differentiate that. So, that's what I'm trying to tell you. For me to come here every Sunday is not easy. It takes a toll, especially with my other college career, professional career. It's not easy. It's really not. But I've made a commitment. Once you make a commitment, there's no going back. It's tough, My wife, my kids, they don't see me on Sundays. How many families do that? Just, I think about my wife and kids, they don't, every Sunday, like they go to, mall to, Chuck E. Cheese's and stuff like that. I'm not gone with them. I don't get time. But why do I do it? Because at least my hard work is helping my students. That's what I live with. It's like, okay, I'm sacrificing here, but you know what? I love these 36s and 35s and potentials of getting into big schools, your scholarship. Where do you want to go? Remember, I told you the best success story ever has been a student who got a 21, who had a 13 ACT score. Till today is the success story, not a 36. It's a 31. He had a 13 ACT score. Was an orphan. Was raised by his uncle and aunt. Was paid. They paid ACT class through his big brothers and sister program, which we didn't take. We returned the money back because he put in the effort and he got a 21. Got a full ride to Wayne State College in Nebraska. That's till today is a success story. You with me on this? So I want you guys to be these success stories. Someday I'm going to share with other students. But it's not going to come easily. Ethan, you taking the December test? I know your score is pretty damn good. I know that. How many more points you want?
2.
Are you putting efforts to get those 2 points?
Yeah.
You are?
Yeah.
Can you make it more?
Yeah.
Okay, good. I know your potential. I know that. Otherwise, I won't tell you that. To be honest, your fair assessment. Your assessment is fine. I would put it 1 to 3 point range, by the way. 1 to 3. I won't exactly go with the 2. But 1 to 3, I would take it. Okay? Because it depends on test. Okay? Anything else? Anything else I can do? Because I want you guys to be in that state. Okay, I had Rob, I had Ryan. These guys did well in my class. And these are the examples of the students I'm going to give in the future. Because you know what? You worked hard. That's what it is. You made it happen for yourself, not for me. Right? Not for me. I can, the only thing I can brag about you guys, that's all I can do. Other than that, there's nothing else I get. You with me on this? I want your hands knee deep in this. And never say anything less than what my potential is. That's all you have to be thinking. Okay, what it takes. And I'm not, like for example, I've heard people say, Thanksgiving is coming. Yes, it's a family time, enjoy. But have a game plan. What the hell are you gonna do with 4 days of not doing any studying? That's crap. I will never buy it. And if you're going on a vacation, fine, have fun. But have a study plan. My son is in 4th grade, we go for vacations, we have a plan. Okay, flight, I want you to study half an hour. When you go to hotel, I want you to just get up in the morning and do half an hour work. Half an hour. If you can't do it, half an hour work in a 24-hour period, you really have a problem in your life. You just do. Because I'm being realistic. So one time I remember we went to scuba diving. We were getting trained up. You know what I asked him? Before we go, why don't you get up, just do a half an hour reading of your choice. Go to the beach, sit there and read. Just half an hour. He's like, that's it. I said, today, I want you to just do half an hour reading. That's all I'm asking for. But that half an hour habit is the thing that changes everything. You guys with me on this? I remember there's a sport in India which famously people like crazy about called cricket. I don't know if you've heard that, okay? It's cricket. I'm absolutely big fan of cricket. There's a guy, he's like the current world champion, the LeBron James of India, we can say. His name is Virat. Okay. It's a big, multi-millionaire that's made around $500 million. He's truly one of the top cricketer ever produced. But I've seen about one thing about him. So he had this tournament they played. It was a 1.5 month tournament. It was long, drained, and India lost in the finals. Of course, it's tough and stuff. But I saw his Instagram picture. Next day morning, he was back in the gym, and there had no games for next 3 months. There was a vacation time for them. But he was in the gym next day morning at 7 o'clock, and he has a hashtag, no days off. And you know what? For me, that showed why he is that good. That was and then for me, I take these things very seriously. I get inspired by, he may be younger than me, but it's an inspiring thing to see somebody is always trying to better themselves. That guy, Michael Phelps, when he was practicing, this is great models. You with me on this? It's a great model. I try to work hard, but there are people who are better than me. So I will look up to them and hopefully imbibe them and be better than them. At least try. And that's what you want, basically, is the urge to be better than you the previous day. Fair enough? Have a happy Thanksgiving. I know you guys are good kids. I know you're going to do well. December 8th is the last day of the class here, and I don't want you to miss. And we all will be combined in that group that day. You with me on this? December 8th. Don't miss. Take care. 5 minutes break.